A woman on a bridge 75 meters high sees a raft floating at a constant speed on the river below. She drops a stone from rest in an attempt to hit the raft. The stone is released when the raft has 700 centimeters more to travel before passing under the bridge. The stone hits the water 4 meters in front of the raft. Find the speed of the raft. So for us to better analyze this problem, let us have first an illustration. So let this be our given. So given be as shown in this figure. Let's say this is the bridge. This is the river. Then the bridge is 75 meters high. Let this be y, the height of the bridge, 75 meters. So according to the problem, the woman drops a stone from rest. So the woman will drop a stone from this point going down in an attempt to hit the raft. So when the stone is released, the raft has 700 centimeter more. Let's say this is the position of the raft when the stone was released. And after a while, because the raft is traveling on a constant velocity going in this direction, so the raft moved, let's say already in this position. After a while, the stone is released when the raft has 700 centimeter more uh, to travel before passing under the bridge. So when the stone is at this point, the raft still has 700 centimeters more, or this is 700 centimeters or equal to 7.0 meters. The stone hits the water. So when the stone hits the water on this point, the water 4 meters in front of the raft, there's still 4 meters from this point to the front of the raft. So this has still 4 meters in front of the raft. So if at this when at this point, when the stone is released, when at this point the raft still has 7 meters, then when the stone is already touching the water, it traveled, from our illustration, it already traveled a distance of 3 meters. And this is that distance because the total distance is 7 meters. Now, so this is now our figure. And all our given was already in this figure. So let's try to solve this problem. So we are required to get the speed of the raft. Let's say that the speed of the raft be equal to VR. So let's solve for this VR. Solution, let's analyze the problem. So if this is now our figure, let's analyze what is the common variable, which is equal to both the stone and the raft. So if we'll analyze the time of the stone going down, let's say TS, the stone going down is equal to the time that the raft traveled from this position going to this point, and during the travel, the raft already traveled a distance of 3 meters. Let's say that this is also the time of the raft, which is equal to the time of the stone to drop from this point going down. Okay, so let's have that assumption that the time of the stone is equal to the time of the raft. Now, since the raft is moving at a constant velocity, we'll just use the velocity equation. Velocity is equal to x over t. Therefore, t is equal to x over v. Okay, so the time of the raft is the distance traveled by the raft over velocity of the raft. But for the stone is in free fall. So if it is in free fall, we need to use one of the kinematic equations that we have derived in our previous lesson. So what is the most appropriate formula that we can use to find the time of the stone using kinematic equation? Well, we only have the y, the height of the bridge. Now we can have the equation y is equal to v initial times time plus 1/2 gt squared. But remember that this y is equal to 75 and the initial velocity is 0 because according to the problem, she drops a stone from rest. Okay, so this gives us an idea that the initial velocity is equal to 0. If the initial velocity is equal to 0, therefore this term will just be equal to 0. What we have now in our equation is that y is equal to 1/2 gt squared, where g is equal to negative 9.8 meters per second squared. Simplifying now our equation, we'll have 2y is equal to gt squared. Okay, then p squared therefore is equal to 2y over g. Squaring both sides of the equation, we'll have p is equal to the square root of 2y over g. This is now the time of the stone, where this time is also equal to the time of the raft. So these equations are equal. So we need to equate these equations, the time of the raft and time of the stone. So let us continue to solve. Ts is equal to Tr, where Ts is the square root of 2y over g equal to x, the distance traveled by the raft over the velocity of the raft. So we are being asked to find the velocity of the raft. So again, simplifying the equation, we'll have Vr, velocity of the raft, times the square root of 2y all over g is equal to xr. Divide this by this quantity, square root of 2y over g. Vr will just be equal to xr over square root of 2y all over g. Now, substituting all our values for the displacement of the raft, the distance traveled by the raft, it is equal to 3 meters, because it only travels 3 meters from the starting point up to this point in the timeline. Now, the displacement will be 3 meters. So this is 3 meters over the square root of 2 times negative 75 meters. We use negative 75 because the displacement of the stone from this position going down, at this point the displacement of the stone is negative 75, using our sign convention that going up is positive, going down is negative. So negative 75 divided by negative 9.8 meters per second squared. So let's now have the value for VR. VR now is equal to, let's compute for this value. Let us input all the values in our calculator. 3 meters over the square root of 2 times negative 75 over negative 9.8. The answer will be 0.7668, or this is approximately 0.77 meters per second. So this is now the velocity of the raft, 0.77 meters per second.